My name is Marcel. Welcome to the next topic in our gentle introduction to GIS tutorial series. This topic will cover vector data. Vector data provide a way to represent real-world features in a GIS application. Imagine you are looking out over a landscape from the top of a hill. Looking out, you see houses, trees, rivers, and roads, and so on. Each of these things is a feature you can represent in a GIS application. Features have attributes which describe them. For example, a road might have a width attribute that describes how wide the road is. Features also have geometry. Geometry defines the position and shape of a feature. GIS applications use three basic geometry types: points, polylines, and polygons. A point is a feature that has attributes and a single vertex for its geometry. What kind of features are represented in a GIS application as points? Trees, lampposts, sample sites for pollution monitoring, named places, and accident sites are all features that can be represented using points. The geometry of a point is usually specified as a longitude, or x, and latitude, or y, coordinate. The attributes of a point describe the point. For example, for tree features, the attributes might describe what kind of tree each point represents. A polyline is a sequence of vertices that are connected. Examples of polyline features are rivers, roads, railways, contour lines, and so on. Each polyline feature also has attributes. For example, a path feature may have an attribute name, which tells us the path's name, and a description, which tells us more about it. Like a polyline, a polygon is a sequence of vertices that are connected. However, a polygon will always form an enclosed area. Examples of polygon features are a school boundary, a dam, an area of land where pollution has occurred, and so on. Because it always forms an enclosed area, a polygon has a minimum of 4 vertices. The last vertex is always at the position of the first, so enclosing the polygon. By now, you might be wondering, where does vector data come from? Vector data is captured using a process called digitizing. For example, we can trace roads visible on a satellite image like this. We will look at digitizing more closely in an upcoming topic. Vector data can also be obtained from devices such as GPS receivers. Vector data can have problems associated with it. One thing to be aware of is the scale of the vector data. Vector data always has a scale associated with it. Small-scale maps that cover a large area are normally not as useful at large scales. This is because for small-scale maps, fewer and less accurate vertices are used to define polylines and polygons. Let's show you an example. Here we have a vector layer in red that was captured at a scale of 1 to 1 million. You can see the boundaries look good at a small scale, but when we zoom in, it becomes less useful. The lines do not follow the coast in our satellite image very well. If we use a vector layer capture at a large scale, like this one in yellow, captured at 1 to 50,000, you will see that the coastline is much more closely matched by the vector layer. Sometimes vector data can have errors caused by problems in the process used to digitize it. For example, polygons can have small gaps or slivers between them which only become apparent at large scales. Undershoots can occur when two line features don't quite connect. This can be a problem if you are trying to create a road map and the roads don't connect. Overshoots can occur when instead of connecting, a line feature runs past another, creating a small segment that doesn't exist in reality. Once vector data has been created, it can be loaded and viewed in a GIS application. One of the advantages of the GIS application is that we can create personalized maps. When vector layers are first added to the map view, the GIS will use a random color and style. For example, when we add this trees layer, a basic symbol and color are automatically used. We can change the default symbol used to one more suitable, like using tree icons for this tree layer. Let's summarize what we have learned in this topic. We have looked at the different kinds of vector data, points, polylines, and polygons. We learned that points are features with a single vertex. And that polylines are features with a geometry made up of a sequence of vertices. Polygons are features with a sequence of vertices that form enclosed areas. Vector features have attributes and geometry. In the next topic, we will look more closely at attribute data. Thank you for watching.